Good morning and warm welcome to everyone watching over PABSON's Distance Teaching Program. And here I am back with again same subject science and the topic acid, base and salt. Today I will be talking about base and alkalis, their differences and what makes them differ from each other. So let us begin. Base. Base means metallic oxides or their hydroxides are called bases. Base means simply metallic oxides or hydroxides. For example, metallic oxides means Na2O. Look at this. Sodium is metal and this is oxygen, means this is metallic oxide. Likewise, CuO, copper oxide. Likewise, FeOS3, ferric hydroxide. Likewise, CaOS2, calcium hydroxide. These are all bases: metallic oxide, metallic oxide, metallic hydroxide, metallic hydroxide. Anyway, base means either metallic oxides or metallic hydroxides. So this is quite easy to understand. There must be metal anyhow. Then if comes oxygen or hydroxide, no matter, it would be base. Now what is alkali? Look, it's very easy to understand. Alkali means base, but not all bases are alkali. All alkalis are bases, but reverse is not true, because all bases are not alkali. Let me make you more clear. Look at this compound sodium oxide. When it is dissolved in water, it forms sodium hydroxide. Look, this is alkali. This compound is alkali. You know why? Because when this compound is dissolved in water, it produces hydroxide ion. See, this hydroxide ion makes alkali. Means whenever base dissolve in water and produces hydroxide ion, then only such bases are called alkali. Otherwise, it is not alkali. I think you got clear points. Those bases which dissolve in water, which produces hydroxide when dissolved in aqueous solution, are called only alkalis. And those bases which do not dissolve in water, which do not produce hydroxide ion when dissolved in water, such bases are not alkali. That is why bases are of two types. Look, bases are of two types. Number one, soluble bases, and number two, insoluble bases. Only soluble bases are alkali. We can write alkali here. But insoluble bases are not alkali, means all the bases are not alkali. Only the bases that goes through this branch are alkali. Means soluble bases are alkali, insoluble bases are not alkali. That is why all the alkali are bases, but all the bases are not alkali. Fine, because all the bases do not dissolve in water. For example, let me bring here one example. Look at this, copper oxide. This does not dissolve in water. It does not produce hydroxide ion when dissolved in water. That is why it is just base but not alkali. Coming to this, this also does not produce hydroxide ion when dissolved in water. That is why it is also just a base but not an alkali. Let me take one more example. You can see lead oxide. See, this is lead oxide. It is base but not alkali. Why it is base? Because it is metallic oxide. Why it is not alkali? Because it does not dissolve in water. It does not produce hydroxide ion when dissolved in water. That is why it is not an alkali, but it is base, as it is metallic oxides. I think you come to very clear ends about these matters. So, just have a look on the screen. There is the definition written what bases are and what happens when soluble bases are dissolved in water. Bases are those chemical compounds which are soapy in touch, means slippery, and bitter in taste, and produces hydroxide ions when dissolved in water. For example, sodium hydroxide, potassium hydroxide, etc. In other words, bases are metallic oxides or their hydroxide. In some examples mentioned over there, you can see when bases are dissolved in water, they all produce hydroxide ion for sure. It is like acid. You must remember, whenever acids are dissolved in water, they sure produce hydrogen ion. Likewise, soluble bases NaOH. Look, this is sodium hydroxide, soluble base, alkali. When it is dissolved in water, it produces hydroxide ion. You can see here, this is hydroxide ion, and this property makes it alkali. Likewise, another example of base which is soluble, potassium ion plus hydroxide ion. Here also you can see hydroxide ion is here. Likewise, one more example of lime water. It is also called lime water, slaked lime, and chemical name of it is calcium hydroxide. When it dissolves in water, it breaks down into two opposite ions and form hydroxide ion. That is why it is also called alkali. Means whenever soluble bases dissolves in water or whenever their aqueous solution is prepared, they all produce hydroxide ion, and that property makes them alkali. I think you come to very clear about these points. The same thing is mentioned in the screen. Only soluble bases are called alkalis. Have a look on the screen one more time. There, see the classification of bases on the basis of strength. There are two types of bases again, like there was acids. On the strength basis, acids were categorized into two categories, that was strong acid and weak acid. Exactly similarly, we can classify bases also, strong base and weak base. I think you can figure out yourself what kind of bases are strong and what kind of bases are weak. Those bases which undergo almost complete ionization in aqueous solution and produces large concentration of hydroxide ions are called strong bases. Since they almost undergo ionization in complete manner, they produce large concentration of hydroxide ion, and that make them very good conductor of electricity. And they are just opposite of acids. In case acids have low pH value when they are strong, bases have high pH value. Just opposite of strong acid, bases are. Means bases, strong bases have higher pH value. You must know pH value ranges from 0 to 14. 7 is exactly the middle point where neutral substances lie. Below 7, acids, above 7, bases or alkali. If you go above 7, 8, 9, 10, the strength of bases gradually increases, and the base with pH value 13 or 14 is strongest of all. They produce large concentration of hydroxide ion, and that is why they become good conductor of electricity due to the availability of large number of hydroxide ions. Weak bases means simple. Those bases which produce less concentration of hydroxide ion in aqueous solution means they undergo partial ionization. All the molecules do not break down. They do not produce large number of hydroxide, and so they are poor conductor of electricity. That is all about base. Now, have a look on the Next screen. Before that, see, there are written some examples of weak bases. Just down the paragraph, ferric hydroxide, copper oxide, lead hydroxide. These are bases which are weak in nature. They undergo very less ionization and produce very less number of hydroxide ions. Let's move to next part of this, alkali again. I already said everything about alkali. Bases which dissolve in water to produce hydroxide ions are called alkali. For example, sodium hydroxide, potassium hydroxide, calcium hydroxide, etc. Alkali produce hydroxide ions with water. The same reactions I mentioned just before. When sodium hydroxide is dissolved in water, sodium ion and hydroxide ions are formed. Likewise, same thing happens with potassium hydroxide. And there is highlighted a sentence, you can see all the alkali are bases, but all the bases are not alkali. The same thing I explained just before, one more time. Bases are not all soluble in water. Only soluble bases which produce hydroxide ion in aqueous solution are called alkali. Rest of the other are not alkali. However, others which are not dissolved in water are not called alkali. Thus, all the alkalis are bases, but all the bases are not alkali. It's like all the people are not man, but all the men are people, of course, right? The same manner it works. Anyway, next screen. Physical properties of bases means what does they feel like, how do they feel like, and what is their shape, I mean taste, and what we feel on the touch of them. This belongs to physical properties. Again, what are the changes that base bring with indicators? Also indicates their physical properties. See the very first point there. Bases are bitter in taste and soapy in touch. That is why, because bases are soapy in touch, slippery in touch, it is used in the manufacturing of soap and detergent. Soap and detergents are soapy in touch with water. That is why it is easy to rub clothes. Against clothes, it is very easy to rub and to wash out stains and dots present there. The second point there you can see, strong bases are corrosive in nature and can burn our skin. Exactly the same way strong acid act, the same way strong acid are dangerous to our skin. They are corrosive in nature, strong bases too corrosive and can burn our skin. The third point is there, bases change red litmus paper into blue, methyl orange into light yellow color, and phenolphthalein into pink color, whereas no effect is observed when it is treated with blue litmus paper. Just have a look here once. Red litmus paper is one of the indicator, one of the ordinary indicator. Blue litmus paper is another colored litmus paper. Anyway, they are ordinary indicator we use to identify the given chemicals, whether they are acid or base or salt. I must say, look at here, if you treat red litmus paper with acid, no effect would be observed, means no change in color would be observed. But with same red colored litmus paper, base shows some changes. Base turns red litmus paper into blue color, and this helps us to identify the given chemicals, whether it is base or is acid. Here is blue litmus paper. Acid show changes with blue litmus paper into red color, means whenever blue litmus paper is treated with some drops of acid, red color is formed. That litmus paper changes into red color. Whenever base and blue litmus paper are treated together, base does not show any change with blue color, means no effect or no change in color is observed. No change in color with blue litmus paper is observed whenever it is treated with base. But if it is the case of methyl orange, see one more time here, methyl orange is another mostly used ordinary indicator, methyl orange. When methyl orange is treated with acid, you can find out methyl orange being turned to red color. Similarly, when methyl orange is treated with base, methyl orange would change into light yellow color. Light yellow color. This way we can find out the given chemicals whether they are acid or base. There is one more mostly used indicator in chemical lab, that is phenolphthalein. I must point it out because it is quite long and pronunciation should be remembered, and we must note its correct spelling too. So, let us write the correct spelling of phenolphthalein. P-H-E-N-O-L, phenol, P-H-T-H-A-L-E-I-N, phenolphthalein. This is the correct spelling of phenolphthalein, one of the ordinary indicators, and this also helps you to find out the given chemicals. When acid is treated with phenolphthalein, no change would be seen, no change, but with base, phenolphthalein changes into pink color. This makes you to identify base easily, because phenolphthalein, which is naturally colorless substance, changes into pink color. This makes you easy to identify the given chemical whether it is acid or base. Okay, let us find out some other properties of base there. Number 4th point there, strong bases or alkalis like NaOH, KOH can dissolve oil or grease. Oil and grease are such a viscous material which are very difficult to wash in case it drops on our any type of clothes. It requires expensive and strong chemicals, but this is the chemical that washes it out, that dissolves it out and makes your cloth goes very clean. That is why they are strong, they are really strong. Let us move to next, chemical properties of bases or alkalis. You can see the screen, there are 4 different chemical reactions are mentioned: base plus acid, salt and water. This chemical reaction we already talked number of times in previous topics also. In the chemical properties of acid, we discussed well on it. While reading chemical reaction topic, we again mentioned this there too. So, here too one more time. Whenever acid and base of equal strength are reacted together, it always forms neutral substances, salt and water. You can see the screen there. In the first chemical reaction, see here, I am talking about chemical properties of base. Chemical properties of base. Number 1, acid plus base, salt plus water. See this. Let us take one base, a strong base NaOH. It is called sodium hydroxide. Strong acid HCl, hydrochloric acid. When hydrochloric acid and sodium hydroxide are treated together, it forms neutral substances, salt and water. I already gave you one good idea to find out what products would form there. See, whenever you find acid and bases are being reacted together, water is CO. So, you can write water directly without even thinking much about it, because you already know about it. Acid plus base, salt and water, done. Acid plus base, salt and water. So, water is CO, water means H2O. Now, what is left there? See, water is formed from hydrogen and hydroxide ion. So, what is left behind? There is left chlorine and sodium. Let us make a crisscross between them. 1 valencies. We can make a crisscross and finally we can get an ACl. This is sodium chloride, common salt, kitchen salt. This is how acid and base produce salt and water. One more example, CaOH2. Look, this is another base, calcium hydroxide. It is also called lime water. When it is treated with one of the acids, say HNO3, it is nitric acid, and they are more or less equal in terms of their strength. So, they produce neutral salt. I already said you water is always formed for sure. Water is sure H2O. Now look, water is formed from this part and this part. What is left behind? Calcium and nitrate radical. Calcium and nitrate radical. Let us make a crisscross, valency 2, nitrate, valency 1, crisscross. That one comes down of Ca and 2 goes down of NO3, thereby forming calcium nitrate. Look, that is why salt calcium nitrate is formed. Okay, for final, acid plus base, salt and water. Acid plus base, salt and water. Keep in mind, please keep in mind, it's very easy. There are mentioned some other examples as well in the screen. You can see base plus acid, salt and water. The final one, let us talk about sodium hydroxide plus sulfuric acid, sodium sulfate and water. Move to next. Chemical properties number 2. Bases with carbon dioxide gas make corresponding metallic carbonate and water. See the second reaction, let me just talk about that. Base plus carbon dioxide, base plus carbon dioxide means metallic carbonate plus water. See, let me take example. Base means NaOH. Again the same base is strongest one, sodium hydroxide, and carbon dioxide means CO2. Sodium hydroxide and carbon dioxide would form metallic carbonate plus water. Let us write water first. What is left behind? Find it out. Water is formed from oxygen from here and hydroxide from here. And I always said you, whenever you find carbon dioxide on the reactant sides, carbonate product is always formed. Means metallic carbonate or some carbonate related compound is always formed on the right side. And whenever you react metallic carbonate with acid, carbon dioxide gas is released in the right product side. So here also happens the same. Here is left sodium, and with carbon dioxide always carbonate compound is formed. So you must make a crisscross between metal and carbonate radical. Here you can find it out, Na2CO3 sodium carbonate, Na2CO3. This is the chemical reaction between base and carbon dioxide. They produce metallic carbonate, specifically it is called sodium carbonate and water. Okay, we have come to the end of today's lecture. Tomorrow means the next week, Sunday, I will be talking about some remaining properties of bases and its other uses. We will talk more about salt also there, and the topic will be indeed. Today this much, I think you understood well about it. Thank you very much for being with me. Stay safe, stay fine, have a good day.